All right. There we go. Okay, a couple more people. So before we kind of just start doing review today, just to kind of recap where we're at in the class, that Module 13, Module 12 quiz, as well as those 3 participation quizzes from this week, all due by the end of the day today, okay? So once those due dates pass tomorrow morning, everything should be, once the due dates pass tonight, everything on Canvas should be updated. I've got it set. I showed you yesterday where it's dropping your lowest module reading, drops your lowest 2 quizzes, drops those lowest 4 participation quizzes. We then will have that final exam that'll pop up right here. In fact, I can even do that while we're here. So save me some time here. So where is it at? There we go. So you won't be able to kind of see this until 10:30 tomorrow. So I mentioned I'd have the availability extended a little bit. So 10:30 to 3:30 tomorrow, that final exam will be available. You can get on at any point that works for you. Once you start, you'll have an hour and 30 minutes, so a little bit longer than the first 2 midterms because there are 5 more questions on that final. I'll be in my office, keeping an eye on my email. If you have any problems at any time during that, it's going to be using that lockdown browser, just like that second exam. So make sure you have a device where you've got that already downloaded. I would suggest using the same one you used for midterm 2. And the only other thing that I wanted to mention, I put up an announcement yesterday, I forgot to mention in class. I think it's set to be, I don't know if it's the end of the day today. I think I put it in the announcement. Yeah, I think it closes at the end of the day. If you could, I'm sure you get inundated with emails. I get a bunch of them from them, but those online course questionnaires helps me out. If I can get, if you guys fill those out, helps me know what's working, what's not working. This is the first time here I've taught this as a summer course. So I'm always interested in getting some feedback. It's a little bit easier for me to kind of think about how to structure things during the fall and spring semesters where these courses move quickly. I know all of you have a lot different schedules in the summer. So any feedback there would be appreciated. And other than that, we've got that practice final exam. Now, all the old practice problems, old quiz questions, we can kind of work through things if people have questions. I can't work through module 12 and 13 quiz questions since they're still available. But if you did have a question, I could work through something similar. So with that being said, that should take us to the end of this class, and we will just be doing review for the remainder of the class. Are there any questions people wanted me to start with, or specific questions you wanted to see worked through, even if it's not a specific problem, maybe a topic? Or
could you start with question 7, please?
Yep. And I'll keep an eye on the chat too. You don't feel like you have to speak up if you don't want to. So if I had a graph like this, right, and we're thinking about this cost structure. Now, I'm not going to try to trick you. This exam will be written in a similar way where it kind of goes through the modules in which we cover them. So, the first 7, 8 questions will be perfectly competitive, next 7, 8 monopoly, etc. So we're thinking back here about a perfectly competitive firm, so perfectly competitive market. If the price is $3.75, what are the firm's profits going to be, and what would the quantity be that they should produce in the short run? Okay. So if I had a price of $3.75, so each one of these grid lines looks like it should be 25. So 375 would be right here. We should choose, right, the optimal profit maximizing quantity where that price, which is the firm's marginal revenue. So we can go back to these perfectly competitive markets. Remember, we said they face a horizontal demand curve. So you could almost even, this is going to cooperate with me. Draw a demand curve here for the firm. All right. This is going to be the equilibrium price. That's their marginal revenue. So that's going to hit marginal cost. Looks like it's here at a quantity of 325. Okay. Also, I've updated my graphics. These are some old ones. The grid lines are a little bit nicer, a little bit larger images when you're taking that exam. So it looks like here that quantity they should be producing is 325. Now, what's going to be true about profits in the short run? Well, that price at that profit maximizing quantity is above my average total cost. So I know profits are going to be positive. Now, I wouldn't ask you in this one necessarily to kind of calculate profits, only because the grid lines don't kind of cooperate with us. So you'll kind of notice like I'm just barely above 300 here. But if I did want to calculate profits, if I didn't just ask if they were negative or positive, how would I do that, right? So every firm when we're thinking about, so we had this marginal cost, we had our average total cost, we had our average variable cost, and we just had an example where, price and quantity here. So we were hitting, here was that equilibrium price, which for the perfectly competitive firm was their marginal revenue. We said that was at a quantity of 325 when the price was told to us to be 75. How would I calculate profits? So profits are going to be the difference between price and average total cost. So we can kind of think about it as my per unit revenue, per unit cost times the number of units that I'm producing. So what we would need is what that average total cost was at that quantity. Let's say I gave you more delineated or kind of, grid lines there to where you could figure out that value. And let's just say it was, I don't know, make the math for myself a little bit easier here. I know this isn't what it looks like on the graph, but let's say it was 325. Okay. Well, I've got a quantity of 325. I've got a price of 375. The average total cost is 325. So I have what? 325 times 25 there. Give me those positive profits. Or pull up my handy calculator in Excel here. Oh, maybe. I don't think you guys can see this. So we go, what? I'd have 8,125 if I wanted to actually calculate my profits there. Okay. So I can always find profits, right? Now, just to kind of add some stuff to this problem. So this was concerning the short run. So anytime you have firms earning profits in a perfectly competitive market, you know that it's in the short run. Okay. So we have positive profits. What are firms going to do? Okay. So if we think about, and this could apply to some other problems that you could see. So let's say we had positive profits and the current price was 375. So let's say I had something that looked like this. This is representing not the firm, but the entire market. So we started out, we had this initial equilibrium price of 375. If there's positive profits, what do we know firms are going to do as we move towards the long run? So as we move towards the long run, if there's positive profits, firms are going to enter this market. So if we're thinking about the supply curve for the market, as firms enter, once again, this class isn't cumulative, but it's comprehensive, in the sense that we're using some things that we've talked about from the previous modules. So a higher number of firms, we said, would increase that supply curve. So let's say, here's my second supply curve, right? What is that going to do? It's going to lower the equilibrium price. Right? Now, here, we'll notice, what did it do to my equilibrium quantity in the market, right? So this is where, if you're reading through questions, make sure you're paying attention if it asks you about the market or a firm, because here's where we could get different answers. So in response to positive profits, firms will enter. What's going to happen to the total quantity in the market? It increases. What's going to happen to the quantity each firm produces? So if this is my equilibrium price, I try to draw this in such a way that, there we go. So here's my second equilibrium price. That's going to now be the marginal revenue, right? After those firms enter. Notice, where does marginal revenue hit marginal cost now? It's actually at a quantity, now I don't know what it would be, but it's going to be lower, right? So each firm is actually going to be producing a lower quantity. So when firms enter a market, the quantity of the market increases, right? We have a higher number of firms, but each firm is actually producing a little bit less than they were at that higher price, right? There's going to be some units here where that lower marginal revenue is now below the marginal cost for those units, and they'd stop producing those. Okay. So we said we know firms will enter until we get to that long run equilibrium, which would be where profits are equal to, well, if price is equal to my average total cost here, we know that profits in this second scenario will be zero. Right? So we start out with positive profits, firms enter, pushes the price down until profits are equal to zero. If we had negative profits, firms would exit, raising that price until profits are zero as well. Okay. So I had a question that asked you, what is the quantity each firm would produce in the long run, right? So if we go back to that graph, in the long run, where's it at? There we go. In the long run, we know that firms will enter, lowering that equilibrium price, which is the marginal revenue of the firm, until we're exactly at that minimum point of the average total cost curve. Now, marginal revenue is equal to marginal cost at, looks like a quantity of 300. So I thought I remember the values correct. And it's exactly equal to my average total cost and the minimum of my average total cost. Okay? So in the long run, I know the quantity each firm would produce would be wherever that minimum point of the average total cost curve is, that's where profits would be zero. So that would be a quantity of 300. Okay. So in fact, I think this one I was kind of alluding to. In the long run, we know the equilibrium quantity would be, well, firms enter until that price gets driven down to where profits are zero. So right at 300. Now, what would average variable costs be? So this is kind of a tricky one. In the long run, if I'm looking at this depiction of cost, why do I know I'm in the short run in this graph? Well, in the short run, I have some fixed costs, so there's always going to be a difference in between average total and average variable. In the long run, what happens to my fixed costs? Everything can be made variable. So this is the idea if we had like building size. Initially, we're locked into whatever building, but we can change, we can move to a different building in the long run if we have enough time. So in the long run, essentially, this average variable cost, it's eliminated. Well, I shouldn't say it's eliminated, but in the long run, it becomes all of my costs will be variable. And so my average total cost would also represent my average variable. So in the long run, we know that the average total cost would also be 300. That would end up being also my average variable cost as well. So that would be kind of 300, 300 here. Okay. Any other problems or any questions on that one before we kind of keep moving? Okay. Any other problems that people wanted to see?
Could you also do number 10, please?
Yeah. All right, so there we go. Yeah, so I can guarantee you, you will see a problem exactly like this. Well, not the same numbers, but the exact same type of problem. So I'll give you a demand curve, right? We're now thinking about, this one may not be quite as clear. I'm probably a little bit more specific on the exam. Hopefully you can kind of see the flow of these questions though. We started talking about monopolies. So here, let's assume that we've got this demand curve, right? What would the profit maximizing quantity be if we're looking for, get more specific here? These are the types of questions we started to look at monopolists for. Right? So 10 and 11 kind of are tied closely. And if you didn't realize in 10, it was talking about monopolist, 11 kind of talks about it. So here we've got the quantity and price that a monopolist would choose. Okay. So I'm going to go here. And we've got a demand curve. So price is equal to 100 minus 2Q. Now, here's where I would, we could have a supply curve that is also like has some slope to it. In these types of problems, I'll give you a constant marginal cost, which is really going to be, if it's a monopolist, their marginal cost is the supply curve. So I'll give you a nice constant marginal cost. Okay. So what we're thinking about visually, to kind of line up with this, is the monopolist faces this downward sloping market demand curve, starts at 100, has a slope of -2. Okay. We then have this constant marginal cost at 40. Okay. So what are we looking for? Well, we're not looking for this point, right? In fact, if I wanted to know what is the perfectly competitive quantity, that would be where supply is equal to demand. So if that was the case, what would I do? I would simply set supply equal to demand. So I'd have what? 100 minus 2Q is equal to 40. Do a little bit of algebra here. Subtract 40 from both sides. Add 2Q to both sides. I get what? 60 is equal to 2Q. Divide both sides by 2. And I get that that perfectly competitive quantity would be out here at 30. Okay. Now, that's not how I solve this problem because the problem is asking me about a monopolist, right? So what does a monopolist do? Well, they're going to make a decision not based off of the demand curve, but off of their marginal revenue curve. So if I'm thinking about what is the marginal revenue for a monopolist, well, it's going to start out at the same point as our demand curve did. However, it's going to be twice as steep. So whatever the slope of that demand curve is, the slope of our marginal revenue curve will be twice that. Right? So I've got what? 100 minus 4Q. So I'm looking for the quantity for the monopolist where marginal revenue, which is that twice as steep as demand curve, is equal to my marginal cost. So what do I do here? I simply set marginal revenue equal to marginal cost. So 100 minus 4Q is equal to 40. It's just a little bit of algebra here, right? So if we're kind of doing a very similar thing that we did before, so subtract 40 from both sides, add 4Q to both sides. You got what? 60 is equal to 4Q. Divide both sides by 4, and I get that what? Quantity is equal to 15. Okay. Any questions so far? So that should be 10, right? That should give me that quantity of 15. That's the profit maximizing quantity for a monopolist. If I then wanted to find the price, so sometimes I will do it this way, where I give you an assumed true value, right? Because if you get the quantity wrong, you're definitely going to get the price wrong, right? Because how do we find that profit maximizing price? So once I find the profit maximizing quantity for a monopolist, the profit maximizing price would be if I go up to the demand curve. Okay. Now I could put this all into one question. So let's say that I simply had a question that asks you for the optimal price and quantity. You would keep using that quantity of 15, right? How would I figure out what price the monopolist would charge? Well, I'm plugging that quantity back into my demand curve. Okay. So for us, right, if we had a quantity of 15, we'll take that demand curve, plug in that quantity of 15, and we would end up with that equilibrium price, that monopoly price of 70. Now, in this problem, I said, assume that what you found in problem 10 was the quantity of 10. That way, if you got 10 wrong, you wouldn't also get 11 wrong. Just kind of, so there we would be plugging 10 in. So we actually end up with what, 100 minus 20, or for question 11, we actually would come up with that price of 80, right? However, if I combine these two questions to where I didn't give you an assumed true value for the quantity, what you actually are doing is plugging in that monopoly quantity back into your demand curve. Okay. So if I'm kind of giving you some, so first of all, any questions on this before I keep moving here? So for this type of problem, I would kind of have these steps outlined. So if I give you a demand equation and a constant marginal cost, I would first figure out or calculate kind of what my marginal revenue equation is. So we said that was just the same as my demand curve, but twice as steep, right? So basically just take the slope of that demand curve, multiply it by 2. I'm then going to take my marginal revenue equation, set it equal to this marginal cost, which in these types of examples, I'd give you a nice constant marginal cost that was just a value. Okay. So once I do that, solve for that profit maximizing quantity. The next step is take that profit maximizing quantity and plug it back into not my marginal revenue equation, but my demand equation. And then from there, I can solve for that missing value, what the price is. Okay. Any other questions on that one before we keep moving? Okay. Any other problems that you want to see here? Anybody else has any problems they want to see?
13, please.
13. Thank you. Yeah. So here we're looking at a single price monopolist. And we're thinking about, oh, what is the dead weight loss that's going to be associated with this? Okay. So if it's a single price monopolist, right? This is where also in these questions, make sure you're reading carefully. And in the exam, I've got things like bolded, a lot more to like if I think it's an important part of the question. So not price discriminating monopolist, but a single price monopolist. So that was just like we worked through just in the last problem. They'll make a decision where that twice as steep marginal revenue curve is equal to this marginal cost curve. So the profit maximizing quantity should be 20. Now the price they set, they'll go take that quantity, plug it into our demand equation, go up to the demand curve. So the price they're going to be setting is 60. Okay. So we can see here that price is just barely above average total cost. I didn't give you the average total cost curve here, so you couldn't calculate profits. But let's just, for a second, assume that that point was like 55. Just like we did for a perfectly competitive firm, when we're calculating profits of a monopolist, it's the exact same equation. So the quantity we're selling, which we just said was 20, that price they're setting, which was 60, and I would have to give you couldn't get it from that graph because I didn't have additional grid lines, but let's just say that it did, and you could identify the average total cost at that profit maximizing quantity of 20 was, looks like right about 55. Okay. So if that was the case, we'd have what? Profits are 100 here. Okay. Now, if I'm thinking about the dead weight loss, what am I comparing to? Well, we said we know the perfectly competitive market is where total surplus is maximized. It was the allocative efficient quantity. Allocative efficiency means we've maximized total surplus. Where would that be? Well, it should be where the supply in the market is equal to the demand curve. Remember, if it's a monopolist, their marginal cost, that would represent all of supply, right? So where that marginal cost curve of the monopolist hits the demand curve, that would be where a perfectly competitive market would kind of set the price and quantity. So where does that marginal cost curve or the supply curve hit demand? That's at a price of 40, quantity of 30. So we're missing out on the surplus of all of those additional 10 units that the monopolist is not producing. So what is total dead weight loss? It's the difference between the marginal benefits and the marginal costs in that market. What represents marginal benefits in the market? That was the demand curve. Here we've got the supply curve, or our marginal cost of that monopolist. So that triangle, that area in between supply and demand, or the marginal benefits and the marginal cost of the market, for all of those 10 units that the monopolist isn't producing, would be kind of this triangle here. Now, it looks like there might be kind of a difference in the slope here. I'll give you drawings kind of where we have a constant marginal cost, so there's no confusion. Like this is an actual triangle. It's not like a bowed out. This should just be a kind of straight line here. I think visually this looks like maybe it isn't completely straight, but it should be, right? So here I've got dead weight loss would be this triangle. So what's the height of that triangle? Difference between price and this marginal revenue were equal to marginal cost. So 40 times that difference would be 10. 40 times 10, it's a triangle. So always multiply that by 1/2. Okay. So 20 times 10 is what? 200? No. 10 times 20. Oh, because it's not 20. 60 minus 20 is 40. 40 times 10 is 400 times 1/2 should give you that dead weight loss of 200. Okay. And just to be,
I'm sorry, even though the average total cost curve overlaps on the triangle where we're finding the dead weight loss, that still doesn't affect the area that we're looking for?
Nope. So the single price monopolist would still choose the quantity of 20 and set the price at 60. So even though there's units here where there's still a difference between demand and average total cost, that doesn't matter because the monopolist is going to stop here at 20 because that's where the difference between the demand curve and the average total cost is at its largest, or that's where profits are maximized. So we know they're going to stop at 20. So we're losing all of the surplus from those additional 10 units that the perfectly competitive market would.
Okay,
Now,
thank you.
maybe where your confusion could come from is if this was a perfectly competitive market, what would be true about profits? Price would be below average totals, so they'd be negative. So what would happen? Firms would exit. Well, if there's only one firm and they exit, we would lose everything, right? So when you're asked about the deadweight loss, right, of a monopolist, you're comparing it just to not if the government came in artificially lower, but if this was if we were at that allocative efficient point, what is the total deadweight loss? Okay. Now, the deadweight loss, if this was a perfectly competitive market, might be larger than the deadweight loss of a monopolist, in which case we don't want this market to be perfectly competitive. So I use this term of perfectly competitive. Really what you're comparing to would not be where a perfectly competitive market would arrive at necessarily. It's the allocative efficient point, which is where that supply curve equals that demand curve. Okay. So this is a unique example where the costs are such a way that we said, okay, where's that? If we're trying to regulate this market, so we know that that deadweight loss exists, right? If I wanted to eliminate that deadweight loss, I would want to lower the price, get it closer to that allocative efficient price. The problem is if I put a price ceiling at 40, we said that price would be below average total cost. If profits are negative, what does the firm do? Exit. We would have all of this as deadweight loss. So if we're trying to think about if this was a natural monopoly, where could we regulate it to? We could only lower the price to the point where profits are equal to zero. So that would be the point where the average total cost curve hits the demand curve. Right? So that's where that kind of comes into play. If we're trying to regulate this market, we can lower the price to 50. The monopolist will now produce 25. Profits are equal to zero, so they're indifferent about staying or leaving this market. We said in practice, maybe I wouldn't lower it to 50. I'd have it just barely above there, so there's some positive profits that convinces them to stay. I don't want them to be indifferent. You know, if I'm indifferent, they don't care if they leave or stay. I want to make sure they stay. But if we're identifying the lowest possible price we could get to where they're indifferent, that would be right here where the average total cost curve hits that demand curve. Now, if we try to, even if we're able to do that, we would still have some deadweight loss, right? Even if we regulate this natural monopoly, we drive their profits to zero, we would still have some deadweight loss. However, it's not near as large as it was before we regulated it. Okay. So we're thinking about what price could we set in order to reduce deadweight loss. We can't lower it to 40, otherwise the firm leaves and we've got even larger deadweight loss than we had before. We can lower it to 50. We haven't eliminated all of deadweight loss, but we've minimized it, right? We've made it a smaller area. Okay. Any questions on that before we keep moving? Okay. So let's assume this one have. I don't know if I got a question here. I'll throw this one at you. So let's say I have the same depiction, and this one gets kind of weird. But this average total cost was coming from the assumption, right? This was kind of that I was setting a single price, and every single unit I sold, I was selling it for the exact same price. Okay, so when I'm looking at the demand curve, that's the one price I'm selling this good for. What is one way we could get to that allocative efficient point? So even though the average total cost is greater than a single price here, if I was to set a single price on the demand curve, if this was a price discriminating monopolist, so they can charge consumers different prices, what is the profit made on every single unit, right? So if I'm price discriminating, every single unit, I'm taking the difference between the price I'm setting and the marginal cost of that unit. And then I would multiply that by every single unit that I'm selling. However, this isn't going to be one price and this isn't going to be one marginal cost, right? I'm looking at like really mathematically the way we should write this. I wouldn't push you guys this far. This is going to be up to what? The allocative efficient quantity. And we would be taking QI times PI. So don't worry about that. This is a little bit more mathematical than I've kind of pushed you in this class. But really what we're doing for the price discriminating monopolist is at the first unit, what's the difference between the price I'm charging? Well, the person would be willing to pay up here close to 100. The difference between that and my marginal cost. So that's the amount of money I made on the first unit. How much do I make on the second? Well, I have to charge a slightly lower price, the difference between that and my marginal cost. So the price discriminating monopolist, their profits are going to look a little bit different than that profit equation because they're charging different prices, okay, for each unit they sell. So they're going to actually go to the point, what becomes their marginal revenue curve? If I can charge every consumer a different price, my marginal revenue curve becomes the demand curve. Where would marginal revenue be equal to marginal cost? Out here at a quantity of 30. So if we had a price discriminating monopolist here, we would actually get to that allocated efficient point and eliminate deadweight loss. Okay. And we would have no need to kind of regulate that market in terms of we've gotten to the point where total surplus is maximized. Now, what was a downside of these price discriminating monopolists? So I think, I guess there's not a question here. So maybe going back to kind of the practice problems, I would look at some more of the price discrimination stuff from module 11. But what would the value of consumer surplus be if I had a price discriminating monopolist here? Well, if I'm charging consumers exactly how much they're benefiting, the price is equal to their marginal benefit. We said kind of consumer surplus is adding up across all quantities, the difference between the marginal benefits and the marginal cost to consumers. If the marginal cost is the price, but I said that I'm setting the price exactly equal to their marginal benefit, consumer surplus, if I can perfectly price discriminate, would go to 0. So even though I've gotten to that point where total surplus is maximized, all of total surplus would be producer surplus, and consumer surplus has now went to 0. Is that a better thing? Well, total surplus is maximized for society, but for our consumers, they're not going to be happy about that outcome. Okay. Excuse me. All right. So we kind of talked about the regulation. What else do we have down here? Is there anything else I wanted to mention? Oh, so this also kind of goes along with 17 and 18, but I wanted to kind of point something out here. When we're thinking about elasticities, and this is something that we haven't talked about since monopolies really. When the single price monopolist is choosing that profit maximizing quantity and a single price, at that quantity, what is true about our marginal revenue? Okay. We said our marginal revenue there would be positive. Okay. So as I'm lowering the price, that's increasing the quantity I'm selling. So we go back to thinking about if I'm thinking about my kind of total revenue, which is price times quantity, we said that every time I'm lowering the price, if the quantity increase is even larger than that, well, the total effect from a change in price on the change in total revenue, which what is a change in total revenue from a kind of change in the number of units I'm selling? So lowering the price, I'm selling more units. That's my marginal revenue. If my marginal revenue is positive, that's telling me that small price changes causing large quantity changes. So anytime we have positive marginal revenue, we're on the elastic portion of our demand curve. Anytime we have a price change and the response of how many more units people buy is less than that, that would give us a negative marginal revenue. Total revenues would actually be decreasing. Large price change, but a small response, there we would say that consumers or the demand curve is fairly inelastic. So if I'm looking at that graph and I'm thinking about, where's it at? the single price monopolist, single price profit maximizing monopolist, if I'm up here, right, at that profit maximizing quantity and price, I'm on the positive. My marginal revenue is still positive here, right? It's 20. It's a positive value. So I know that they're going to be on the elastic portion of their demand curve, right? So profits are positive, and we're on the elastic, right? At that quantity that they're producing at, the demand curve is elastic. What if I change this question to a price discriminating monopolist? Well, if they're price discriminating, we said they would be out here where marginal cost is equal to the demand curve because the demand becomes their marginal revenue. Now, here I can see that my marginal revenue, I don't know what the value is, but it looks like it's going to be negative. If my marginal revenue is negative, a price discriminating monopolist can actually end up on the inelastic portion of the demand curve. Okay. So kind of a key difference there is if they're a single price monopolist, they can potentially, they're always going to be operating at a point, as long as the marginal costs are anything, it's going to hit marginal revenue at a positive value. The single price monopolist is always on the elastic portion of the demand curve. For a price discriminating monopolist, it depends. Kind of depends on the slope of the marginal cost relative to demand. But in this example, we see that, okay, marginal revenue, if they were charging a single price, is negative here. So for a price discriminating monopolist, they would actually be on the inelastic portion of the demand curve. Okay. And then we kind of get some similar things if we're thinking about, here we've got collusion, so this is a little bit different. But I could do the same thing with kind of tables here as opposed to a graph, right? If I'm identifying that profit maximizing quantity and price, what tells me whether or not the demand curve is elastic or inelastic is what the sign of your marginal revenue is. If marginal revenue is positive, you're on the elastic portion. If marginal revenue is negative, we're on the inelastic portion. Okay. Any other problems people want to see there? So I think for the sake of this example, and this might be helpful for the exam, and I'll do this math pretty quickly. So 17 and 18 are looking at like duopoly models. So this is going to be where you're thinking about like if firms act as well, if they break the agreement or not. So it's kind of like the game theory stuff. Let's say I gave you this table. How would you calculate? So I've got price and quantity. If I didn't give you revenue, how was I coming up with these total revenue values? I was simply taking the price that I was selling times the quantity, right? So if I copy this down, hopefully I get all the same values. Yep. How would I find my marginal revenue? Well, marginal revenue, we said, was just going to be the change in my total revenue. So I could do this by hand. I don't have to do it in Excel. Divide that by the change in quantity. Well, here, all my change in quantity are 100. So if it helps me to think about this, all my changes in quantity are 100 here. So I could calculate my marginal revenue at every single price quantity combination. So if I had, some marginal costs, and I identify, let's say, I don't know, let's say the marginal cost was 25. Where would the marginal revenue be equal to marginal cost? Right here at a quantity of 800. But because that marginal revenue is positive, I know that I must be on the elastic portion. So here, anytime marginal revenue is positive, we know that the demand curve, we're on the elastic portion of that demand curve. Okay. As soon as that marginal revenue becomes negative, so let's assume we go back to that example, and instead of kind of thinking about this twice as steep marginal revenue curve, if my marginal cost is 25, well, notice I'd have to keep going down to figure out where that hits my demand curve. So 35, 30, 25, somewhere down here. But notice, once I get to that quantity of 1100, so I know that that marginal cost of 25 hits my demand curve way down here. I'm already on a portion of the demand curve at a quantity of 45 where marginal revenue has become negative. I know I'm on the inelastic portion of the demand curve for any quantity past this or at any price below that value. Okay. So if I had perfect price discrimination, I'm looking at this at a table. We said, what are they doing visually? They're looking at where the demand curve hits marginal cost. So where would that marginal cost of 25 hit my demand curve? What price? Be down here where I'd have negative marginal revenues and I'm on the inelastic portion. So whether or not we're doing it from kind of a visual here, right, or we're using a table that represents the demand curve and then given a marginal cost, we can determine whether or not marginal revenue is positive or negative. And then from there, we set kind of that relationship that has to elasticities. All right. Any other problems people want to see worked through here? I haven't done any game theory stuff. I don't know if there's any questions that people have over that. Nobody else? No other problems, even if it's something that we went through yesterday. We kind of went through these monopolistically competitive examples. Okay. I'll work through 17 and 18 because I know that I'm going to give you something pretty similar on that final. So let's say I gave you this kind of price quantity, I gave you the demand curve, and I gave you the corresponding total revenue. Even if I didn't give you total revenue, we already talked about, well, where is that coming from? It's just price times quantity. So if I had constant marginal cost of 60, okay, and I've got two firms and they agree to act together as a monopolist. So if they agree to act together as a monopolist and they hold true to that agreement, what is the equilibrium price and quantity each firm will charge and each firm will produce? So this is all of market demand, right? So if we're thinking about what we're doing here, we've got some demand curve, and I think price it started out at was 100. Yeah. So we had price, quantity, we had 100. Here is our demand curve, right? We had a constant marginal cost at 60. So if they're working together, right, kind of holding true to this agreement, we're not going to look for where the marginal cost hits the demand curve. We're looking for these two firms are acting like a single price monopolist, so they're going to face a twice as steep marginal revenue curve. So what we would go through and do is just like we did when we were talking about elasticities, I would go through and calculate the marginal revenue for every single quantity. So the change in total revenue divided by the change in quantity. Change in total revenue divided by the change in quantity. If I do that, I'll see, okay, where would the last unit, or sorry, what is the last unit where that marginal revenue would be greater than or equal to now not a marginal cost of 25, but a marginal cost of 60. Okay. Well, for the first 100 units, marginal revenue is above marginal cost, so I'd produce them. Next 100, marginal revenue is above marginal cost. So I keep going until, okay, marginal revenue is greater than marginal cost. At a quantity of 500, that marginal revenue is not greater than the marginal cost. Okay. So what's happening? Well, also to kind of point this out, notice every time quantity was going up by 100, how much was price falling by? 5. That was the slope of our demand curve. Every time quantity was up by 100, how much is marginal revenue falling by? Should be twice as much. Sure enough, it's going down by 10. So the last unit where marginal revenue is above marginal cost would be at 400. Okay. So that's going to be the quantity that the two firms agree to produce together. The point that they're at on their demand curve there would be at a price of 80, right? So if we're thinking about what we just identified, this was the total quantity in the market, and the price that they would set would be up here at 80, okay? Now, this question asks about each firm. So if they together are producing 400 total units, charging a price of 80, each firm will charge a price of 80, but we have to split demand. So we're each going to be producing 200 units, right? This is the total quantity in the market. If we have two firms, duopoly market, so we have two firms, then each firm would produce half of that. Okay. What if instead we had the same setup, but they break this agreement, right? So we said, okay, I'm going to produce 200 units, you're going to produce 200 units. But what if one firm says, I'm going to say I'll produce 200, but I'm actually going to produce 300? What would happen? Well, the price would go down in the market that people were willing to buy. So they couldn't charge a price of 80 anymore. The price would be 75. So they'd be losing some money on every unit they sell. However, the firm that chooses to sell more units, they're going to sell what? 100 more units. So they're going to more than be compensated for by that reduction in price. Now, the firm that keeps producing 200 units, they're making less than before, right? They were making 80 times 200 before. Now they're only making 75 times 200. So there's always this incentive to be the one firm that breaks the agreement, and you could actually increase your profits. So we said, what happens in the kind of long run when they break this agreement? Well, the optimal kind of quantity to choose, or they keep undercutting each other's price. However, if that marginal cost is 60, what's the last unit where the marginal revenue, right, that new price of 60, it's not the monopolist single price anymore, where would we be at on the demand curve? So if we keep undercutting each other's price, we know the two firms will end up at that perfectly competitive quantity where that marginal cost hits my demand curve. So if we look there, where does that marginal cost hit that demand curve, or where is the price equal to 60? Looks like at a quantity of 800. Now that's the total quantity in the market. So how much is each firm producing? We get down to that lower price of 60, and each firm will be producing half of that, right? So 400 units. So if they break the agreement, we end up at that perfectly competitive outcome where the price is lower and the quantity each firm produces will be higher. Okay. Any questions over either of those before we keep moving? Let me move this over a little bit so I can see if I've got any other problems that people wanted to see kind of work through here before I start picking and choosing a little bit. Let me go back here, think about some of this stuff. Well, we have 30 minutes. So I want to go through one kind of related. I think we went through 29. Through 29 pretty quick. I've got something kind of similar that we might want to think about, wink, wink, if we're thinking about monopolistically competitive markets. Part of the discussion that I had in that video that replaced Tuesday's class was something like this, okay? So we'll start out with this scenario. Let's assume that I can spend a lot of money on advertising, right? So it represents to me a huge fixed cost, okay? So I spend all this money on advertising. What's the goal? Well, we could go through the game theory thing where, everyone has advertising, whatever. Let's assume that I'm the only person advertising. And so as a result, I can increase the demand for my product, okay? So if I'm a monopolistically competitive firm and I think about, okay, originally, maybe I started out here. Here's my demand curve. Right? And I want to get this. Here's my average total cost curve. Here's my marginal cost, hits it at its minimum point. And then here's my twice as steep marginal revenue curve. So at that profit maximizing quantity, right? Here would be price of these monopolistic competitive firms. It looks kind of similar to a monopolist. They choose where marginal revenue is equal to marginal cost. That's their profit maximizing quantity. They then go up to the demand curve to set the price. Now here I started out with a scenario to kind of help make this point, where the price was equal to the average total cost or our profits were equal to 0. If I've been able to spend all this money in advertising, there's going to be two effects. So one is that I saw an increase in demand. The other is that I've just increased my fixed cost, which is going to do what? Increase my average total cost. Okay. So I can think about, let's just draw out the effects of each one. So if I've increased my average total costs, right? So I've spent all this money in advertising. What is that going to do? Well, if it doesn't change my marginal cost, right? It was a fixed cost, so it didn't depend on the quantity I was producing. I've seen no shift in the marginal cost or the marginal revenue. Excuse me. That fixed cost going up won't change the price, won't change the profit maximizing quantity, right? However, what have I done? The price I'm setting is now below my average total cost, so that would decrease my profits. Okay. So why am I willing to spend all this money on advertising then? Because, and I'm going to put this on a separate graph just to make it a little bit, if I can move my mouse there. There we go. So that we don't have too many things going on. Okay, so that was the impacts of just simply spending the money on advertising. If I had kind of a similar kind of setup here, so I've got my average total costs, I've got a demand curve, right? I've got marginal costs, and I want to start out with zero profits, right? And this is a little bit wonky, but you got it. So let's say I'm starting out at this quantity. So where marginal revenue is equal to marginal cost, they go up here to kind of set that equilibrium price, right? And we started out with zero profits. If by spending this additional money on advertising, if instead of thinking about the impacts that the cost would have, let's think about, well, what impact would the fact that I increased the demand for my product had? So we said, if I could see an increase in my demand curve, that's also going to increase my marginal revenue curve. Where does marginal revenue now hit my marginal cost? I'm somewhere out here. We go up to the demand curve to set that price. Right? And if I haven't changed, right, I'm not looking at the change in my average total cost. I'm just thinking about the demand curve shift. What did that demand increase do to my price and quantity? It increased the price, increased the quantity I was producing. And what has it done to profits? Well, now price is not equal to average total cost. Price is way above average total cost. So it's increased my profits. So if by spending money on advertising, I've increased my cost, but I've also increased the demand curve, what's going to be my total effect, right? So instead of drawing these all in the graph at the same time, because then it would depend like how large that shift in average total cost was, how large the demand. Well, notice if these happen at the same time, what's definitely going to happen to price? It's going to go up, right? This didn't change price, this increased it. What's going to happen to quantity? This didn't change it, but this increased it. What's going to happen to my profits? I don't know. It would have to depend on how much money did I have to spend and what was the size of the shift in demand I saw for my product. So the answer there, if I'm thinking about if I gave you a list of things that are true, well, price will go up, quantity would go up, but I don't know. Profit changes are indeterminate, right? I can't say unless I knew something about how much money was spent relative to the size of the demand shift that I saw for my product. Okay. Any other questions on that before we keep moving? There's also another thing that I want to point out, and it's in one of those practice problems, and not making the point about advertising, but if I was asking you something else about changes in demand. So instead of thinking about profits here, I just want to focus on the markup. Okay. So I'll do the opposite shift just so that we kind of have more examples of things here. So let's say this was the demand and the marginal revenue curve. So here I've got my initial quantity, my initial price. and the value of my marginal cost. Okay. So we said that difference between price and marginal cost, we were going to give that kind of this terminology, which is our markup. Okay. So if I instead saw a demand decrease, but like no change in the shift, or sorry, no change in the slope, it was a parallel shift. And I'll kind of draw this out pretty extreme here just to, so here's my demand curve. I'm going to try to get this to be pretty parallel to here, right? So if I saw a demand decrease for the product, so what could cause this? Remember, if we had positive profits, what are firms going to do? They're going to enter that market. So kind of similar to when we went, going all the way back to perfectly competitive markets. Let me grab this here. So we said if we have perfectly competitive markets, firms enter if there's positive profits. That pushes down the price, and the price was our marginal revenue curve. Okay? And it was also the same as the demand curve the firm faces. For monopolistically competitive markets, as firms enter, our demand curve is still going to decrease. It's just that now it's not a horizontal line, right? We're getting a smaller portion of overall demand. So when more firms enter, we're getting a smaller portion of demand, or we're seeing a demand decrease for the firm. Well, what's that going to do? It's going to lower that profit maximizing quantity and lower that profit maximizing price. So it's going to lower the price and quantity when we see a demand decrease. But notice also what's going to happen to my markup. That gap, if I'm looking at a lower quantity, that gap in between price and marginal cost, my markup's also going to be going down. You can kind of think about it this way, a more intuitive way to remember this without drawing graphs. If I have more firms enter, there is more competition. I can't get away with charging a price. The difference between the price I can charge and what my costs are, that gap is going to get smaller, right? I don't have as much market power as before when more and more firms are entering this market. So when we see these demand decreases, that'll push the price and quantity down, and it'll also decrease my markup. If I had the exact opposite, like in our previous one where we saw a demand increase, we saw there that pushed the price and quantity up, and what'll end up being true there as well at higher quantities, right? I'm also going to have, if there's more demand for my product, I'm going to have more market power. I should see that my markup's a little bit higher as well. It's kind of some intuition you can kind of use there. But you can also draw it out and kind of see that visually as well. Okay. All right. Let me think. So I wanted to mention the markups there. Thinking about the problems that I have on the exam. Let me think if there's anything tricky from game theory that we haven't. I don't know. I think this stuff, it should be somewhat pretty straightforward here. Any other problems people want to see? Oh, I can start picking and choosing some, but okay. Let's think about, I don't know, this one, maybe give some extensive form games a little bit of time. So if we're thinking about how we solve kind of these extensive form games, we said we always start out using backward induction. So you're going to start out using firm two's payoffs. All right. So firm two's payoffs are on the right here. Firm one's payoffs are on the left. Right. And I always keep that the same on the exam and the questions I've written. I've added in like terminology where it says, firm one's payoffs are written are on the left, firm two's are on the right. I'll always keep that the same. So if we're looking at this, what is firm two going to choose to do? Okay. So I'm going to try to do this on here. Okay. So if I'm firm two, I'm just going to write this out for us instead of messing around with this. So we've got firm one, they've got two decisions to make. We got firm two. So we have what, 250, 250, 400, 300, 300, 400, 350, 350. Okay. So if I've got this game and I'm thinking about what is this, Nash equilibrium, right? So the first thing I'm going to do is think about, and you could almost like, I'm going to solve this for whoever is making that decision second. So I'm not even going to worry about the first person's payoffs at all. Okay. So if I'm solving this game, what is person two going to do? Well, if firm one chooses, and here I should probably write in, it would help if I had in their choices, right? This is what? Quantity of 30, quantity of 40, 40, 30, 40, 30. Okay. So if firm one chooses to produce 30 units, what should firm two do? Well, if they produce 40 units, they get 400. If they produce 30 as well, they get 350. Which of those is better? 400. If instead firm one produces 40 units, what should firm two do in response to that? Well, if they produce 40 as well, they get 250. If they produce 30, they get 300. So we're first going to identify firm two's best responses to both of firm one's possible choices. Now, we'll notice that depending on what firm one does, firm two chooses different quantities, right? They have a different choice. So this is not, right? We would say they don't have a dominant strategy. What they choose to do will depend on what firm one does. Okay. So firm one, knowing this, says, okay, I know what the payoff structure looks like in this market. So I know if I set a high quantity, firm two is always going to choose a lower quantity, right? So I know that this isn't a potential outcome. And then if I set a lower quantity, I know firm two will always choose to set a higher quantity. I know this isn't a potential outcome. So when I'm making the choice between setting quantity at 30 or 40, if I set it at 40, I know firm two would produce 30 and my payoff would be 400. If I produce 30, I know firm two would choose to produce 40. My payoff would only be 300. So which of those is better for firm one to produce that higher quantity? So what is our Nash equilibrium going to be? Firm one chooses to produce 40 units. Firm two chooses to produce 30. And that would be our Nash equilibrium. Now, it's not a dominant strategy equilibrium in the sense that the strategy choice of firm two, right, depends on what firm one does. So that's how you would kind of go through and solve those extensive form games, right? So I can almost guarantee you'll see something that looks similar to this, with two players each having two potential choices, whether or not it's prices, quantity, whatever it is, and then kind of the resulting payoffs. Okay. Excuse me. So we got about 10 minutes left here. Let me think if there's anything from early on that I wanted to mention that we didn't talk through. Oh, so one thing I would always make sure you're checking in these examples, and I don't think that there's some, if we go back to like problems 1 and 2. And so let's see, I gave you a current price of 1, average total. So it didn't do this here, but I'll kind of do it. Let's say we had problem 2, that was kind of our scenario. The price here of $1 is below kind of the average total cost. Okay. If I had a slightly different example, so here price is below average total cost, what would the profits of this firm be? Okay. Technically in this example, I'm assuming that they're staying open. What I could do is throw in additional information and then ask you whether or not this firm decides to shut down or stay open. Okay. So it's going to look more similar to kind of the questions down here, 27 and 28. So let's assume, though, we could do the same thing. I know that we did them yesterday for the monopolistic competitive market. So let's do something like this for the perfectly competitive markets. So let's say I took question 1, and I also gave you the average variable costs were $2. Okay. Well, if the average variable costs were $2, right, when I'm thinking about what firms are going to do in terms of profit maximization, we said that
as long as the price is ever above my average total cost, well, everything's good there because I know profits are going to be positive. So if we remember our profit equation, it was quantity we're selling times the difference between price and average total cost. Okay. If the price ever falls below my average total costs, right? So this is kind of like scenario 1. Scenario 2, if my price is below average total cost, I know that I'm going to have negative profits. If I have negative profits, I kind of have 2 decisions to make. Okay. We said that, so like 2B would be if price is above my average variable cost, profits will still be negative, right? But I'll be maximizing profits if I stay open. Right? And I shouldn't say 2B, right? 2A, and then this would be 2B. If price is below my average variable cost, we said then they should choose to shut down. Okay. So in our example, we had a price of $1. They were at the profit maximizing quantity. If they stayed open of 100, average total cost was 3. And these are really easy values here. I might give you some slightly harder ones on the exam, but I wrote just to kind of get at the principles here. So price is definitely below average total. I know my profits are going to be negative. Okay. Now, if I stay open, I still calculate profits the exact same way. However, if I shut down, we said our profits simply become negative whatever my fixed costs are. Okay. So if I wanted to calculate profits, if I stay open, what would that be? Well, I'm selling 100 units times that difference between price and my average total cost. I'd have what? Negative 200 here. Okay. Now, if I shut down, I don't use that profit equation. We said our profits would be negative whatever our fixed costs are. Well, I didn't give you fixed costs, but we know that we can calculate fixed costs by simply taking the average and multiplying it by the quantity we're producing. Well, I don't have average fixed cost, but I know that my average fixed costs are just the difference between my average total and my average variable. Okay. So if I didn't give you like a long run example with these perfectly competitive markets, and you would really operate these questions in a very similar way for monopolistic competitive markets when you're just calculating profits. So now I've got an equation that I do have all the information. I can act, this will give me my fixed cost, negative fixed cost would be my profits. So this would be what? Negative 3 minus 2 times 100. So notice if I shut down, my profits are only negative 100. That's better than negative 200. I should shut down. Okay. Now I could work through this the exact same way if I just change what my average variable cost is. Well, if I change average variable, staying open would be the same thing. So let's say now instead, excuse me, let's say I told you the average variable cost, do a different color, was only 0.5. Okay. Well, price is now above my average variable cost, so I know I should stay open. If I do that, I calculate profits the exact same way, quantity times the difference between price and average total costs. But now if I'm calculating my fixed costs, the difference between my average total, average variable times quantity, well, now I get what? 3 minus 0.5 times 100. So here I would actually now have negative 250. So notice when that price fell below, when the price was now above, before we had price below average variable cost. Now that the price is above my average variable cost, if I shut down, I actually have larger losses than if I stay open. Okay. So knowing that profits are negative fixed costs, and then how do I calculate fixed costs? You don't have to like go through this step every single time. If you want to just remember that if I shut down, I can calculate my fixed cost kind of using this equation. You can even prove to yourself why you should shut down or why you should stay open and calculate what the actual profit value should be. So I could ask you a question where I don't ask you if you shut down or stay open. I just give you this information about price, average, total, average, variable cost. I then ask you to calculate profits. You would have to know that if price is above our average variable cost, I should not shut down. I'll stay open and calculate profits this way. But if I had a scenario where price was ever below my average variable cost, I shouldn't stay open. My profits won't be negative 200. I should actually shut down, and then my profits would only be negative 100. So I would know that form of the kind of profit equation, how you calculate your fixed costs when you shut down, knowing that your profits there would be just negative fixed costs. Okay. So we got a couple minutes. Any other questions people have about the exam, logistically or anything else before we kind of end the recording here in the next minute or two? Okay. So if I'm studying for this exam, I think this practice final is probably the first thing I want to make sure I can work through and feel pretty comfortable with. After that, what I would do is go back and review these kind of practice problems, review the old quiz questions that you can kind of have access to. So modules 10, module 11. But yeah, these practice problems for each module would also be some additional good study material as you're kind of preparing for that final. If you've taken the quiz and you have any questions, feel free to email me. I can kind of give you an explanation if there's one you got wrong and you can't really figure out why, or can't go back and understand why. Feel free to kind of shoot me an email and I can try to get you a quick response when I'm able to. So I should be able to respond to emails through like 4 o'clock today, and then I'll look at my email first thing when I get here in the morning, probably right around 8 a.m. And kind of get you some emails before you sit down to take that final. Okay. All right. So there's no other questions. Kind of end the recording here. So thanks for a good summer semester. I know it's quick. I know it's a lot of information thrown at you. I know it's hard to kind of keep up on it, but I appreciate all of you who sign on live as well. Makes me feel like I'm not just talking to a screen. And I good luck on the final. And once again, any other questions, please send me an email as soon as possible, and I'll try to get back to you so you have all the information you need before we take that final exam.